Uh-oh. That's what you always want to start with. Uh-oh. Okay. Yeah, seems like I'm on air. All right. So, thanks for tuning in. I don't know if I have any viewers yet. Sometimes it takes a little while for these things to show up in the counter here. If you didn't know, my name's Darius Kazemi. I make weird stuff on the internet, and today I was inspired because there was a tool that is that was published, I think recently, that I wanted to just play around with, and I thought, why not play around with it with an audience? So I'm going to share my screen, do a screen share here. We will do, yeah, we'll do the whole display, I guess, because I need to show you my terminal. All right, so what I want to show is things that you can do when you're playing around with regular expressions. But in particular, we've got this tool called randexp, and what it does is it creates a regular expression. You give it a regular expression, and it generates text that matches that regular expression. Now, if you don't know what a regular expression is, typically it works the other direction. If I have some text, I'll pull up like rubular.com here. So if I have some text like, "Hi there, everybody," I'll make this bigger so people can see it. And I want to capture a piece of that text. I could make a regular expression that just said, I could say "there," and it would match the word "there." Or I could say "e," and oh, hey, now it's matching the letter E. And then you can get very complex with these things. I can say match "hi" or "there," and now I'm matching both "hi" and "there" because it's an inclusive or. Or I could do something like match all letters that are like part of words, so it just matches every single letter there. I could say match every instance of one or more character in a row that's not a space, and so now it's capturing these whole words here, "hi there" and "everybody." I could say give me what's a good example? Give me the letter E with whatever letter comes after it. So I'm just going to do E and then dot question mark. Oh, that's not going to work. Dot question mark plus. There we go. There, no. Plus dot. I don't know. It's close. Well, that one didn't work out. This is Ruby regular expressions anyway, so I'm not 100% sure if they're the same as JavaScript ones. But you get the idea. What you're doing here is you're taking you're matching patterns in text. And so what this does is it flips it on its head. So what I'm going to do is I'm going to provide it a regular expression, and then it's going to give me a random string that satisfies that regular expression. So if I put a word in here, just the word hello, and I hit enter, it's just going to give me hello, because hello is a string that matches the regular expression hello. If I say give me hello or goodbye, and I generate, then if I do it a bunch of times, I'm just clicking this a whole bunch, then it's going to give me either hello or goodbye. All right, that's kind of neat. But now I can do things like string things together. So I could say, I could string consonants and vowels. So I could be like, okay, K or B or P, so like hard consonants, and then we'll do some vowels. We'll do like some diphthongs, for example. We'll do like OU and A, E, and I don't know. That's all the ones I can think of right now. Sure, we'll do those, and then let's do some like sort of like L, like light sounds. So we'll do some consonants here. We'll do L and Y. Sure, and then we'll generate. And now we're making words that all kind of sort of sound the same, but they're different. Pale, buoy, bay, cool, powl, but they all have this sort of explosive, this plosive beginning, and then this sort of lilting end to them. And so the cool thing about this is you can generate words that are all sort of aesthetically coherent to one another. And what you could do with this is make up coherent fake languages, for example. I want to swap over here and talk a little bit about isoglosses. So an isogloss is a pretty cool thing. It's a thing from linguistic studies where you map out languages, but like parts of languages. So for example, this isogloss here is the Faroe Islands, and it's talking about places where different language sounds exist on these islands. I don't really know how to read these at all, but you kind of get the picture. It's like, oh, there's this border, and within this border, this particular sound appears a lot in language. So isoglosses are pretty cool, and I've always wanted to generate isoglosses on the fly, because you always see people generating world maps for games and that sort of thing. And usually it's like, oh, we got the boundaries of countries, and we've got like fortresses and things like that. But I'm interested in like, well, what if we generated isoglosses and then use those isoglosses to name things in the different parts of the map? So like two things that are very far apart from each other here. So let's say like this is our world map, and we have a city here, and a city here, and a city here. These two cities, because they sort of sit geographically near each other, will have names that sound kind of similar, but like across an ocean or on the other side of the river or something, this city and this other city will have a different sounding language. And so when you look at this map, it'll have this almost natural order to it, where it's where it just kind of makes sense to read it. And so I've always wanted to build one of these things. I'm actually going to go and shut the window in this room. I will be brief. It was making a lot of noise. It's probably better now. So, okay, we want to make a map sort of like this, and we want to make our isoglosses, and we want to do all sorts of things. And we have sort of little pieces of this already here. So what I'm going to do is, so I cheated a little bit. We're not starting completely from scratch here, because I already kind of know what I want to build. So what we have here is it's just a canvas. It's a plain HTML canvas. I'm not going to rely on too many different weird libraries for this particular coding session. I try to do as much as I can in raw JavaScript. And then we also have this rand exp thing built into it as well. If I go here to my console, I'll make the console a little bigger. If I go here to my console and I run, like I had an example in there, but this or that, and then hello, goodbye. That hello, this goodbye, this goodbye, this hello, that hello. So, okay, so we have sort of our basic regular expression engine in here. So what we're going to do is we're going to start coding. So we have, let me, all right. So we're working in this, this JavaScript file mostly here. I will note I'm running this thing called live.js. It's this bit up here. Live.js is pretty cool. It's a one-line JavaScript. It's a single JavaScript file you can drop into any project, and what it does is it live updates the page that you're working in, so you don't have to like save and reload. You can just save the source file and then it reloads for you. So, so what I have here is I have my excuse me, I have my pick function here, which I just use in all my projects. It just lets me choose something at random from an array. I just set up a very basic canvas here. I'm setting up a basic fill style of black, and I set the font to 12-point sans serif. I'm actually going to make that a little bigger. We'll make it 20-point sans serif. And then we have this step function, which is running once every 60 seconds. I don't think we even necessarily need to be running this as an animation, but I like to animate by default, and then I can remove animation later if it's not necessary. So all this is doing right now is clearing this rectangle over and over. If I add a line here, you'll see I have a sort of a line draw function in here, because drawing lines in plain canvas is like 6 lines of code normally. So I'm just gonna, so I can like draw a line from 0, 0 to 300, 300, and I can make it green. And I go back here, and whoa, there it is. There's our green line. So we have some basic drawing going on here, and then I could also, you know, draw text on here. So like at 350, 350, I'll put this is just to the southeast of the green line. Did it work? Do I have fill text wrong? It's possible I have fill text wrong. I always look this stuff up. It's not even like, oh, it's text first and then the coordinates. Okay. Mistakes, aka programming. Go back here. Hey, there it is. This is just to the southeast of the green line. All right, so we've got super basic drawing going on here as well. So I guess the first thing we should do is just some of the fun stuff, right? We should come up with some fun languages and how we're going to distribute these languages around. So I'm going to just grab this thing that I already was playing with around here. So this regular expression is kind of interesting. It's got a capture group here in between these parentheses. So this is like al or ba or za or ka. And then the next part is not a capture group. This just says pick any of these characters, C, K, B, Z, or D. And then we have these al, el, il, ul, also in a capture group. And then, so actually, I'll remove this first. And so we'll just generate here, and okay, Babel, Zabel, Kassel, Zadil, right? Okay, so these are all sort of aesthetically coherent with each other. Now, because we have capture groups here, we regular expressions actually keep track of the result of these things. So if it goes through and it says the result of this capture group here is za, we can actually repeat za by going /1, because this is the first one here. So if I do this, now it's, oh, Kazilka. So it'll always have the same first 2 and last 2 letters. Bazalba, Aldilal, Kabilka, Alsilal, Sabalza. And so this is kind of cool. Could this actually make Bazinga? No, thank goodness. Okay. And then I could repeat them again as well, or I could repeat the last one. So this time I'll repeat this. So instead of Zabalza, it would be Zabalal, Kadulul, Kasilil, Basilil, Bazalal, Albulul. Okay. So first things first, let's just have some fun with this thing right here. We don't want to get super fancy. So we'll go back here to our code. Oops. Hold on. Here's our project. Let's just, yeah, so that's working as expected in there. So we will now go ahead and add this to here somehow. Okay, so let's create an object for, I don't know, a city, right? So we will say, we could do this with, like, we could generate our own classes or things like that, but we'll just do, I'll make it a function, and it'll be called city, and it's going to, when I call city, it's going to return an object with certain properties inside of it. So it's going to return this object, and inside the object, we're going to keep track of position. So we have an x coordinate and a y coordinate. It'll be 0, 0 by default, and a name. And so the name, well, right now we'll just call it, you know, I don't know, city by default. Let's just say this is what a city is, right, to begin with right now. And let's start drawing these cities on the map. So we're going to get rid of those lines, and so that should just, like, go away now. Yeah. So now we have no lines there. So let's draw a city. Oh, so we want to actually give this a draw function. So we're going to give it a function called draw, and that draw function is going to do the drawing. So what we're going to say is we're going to say ctx. We want to make a let's make a rectangle. I always you know, mdn draw rect. I always search for stuff on mdn because it's pretty good. Here we go. So there's this fill rect here. So we'll go here and we will fill rect on our canvas, and we will start at this dot x, this dot y, so we know that we're referring to the x and y that's part of this object here. And then, I don't know, we'll make it like 20 by 20 pixels to start with. I don't know. Who knows? It's all a crapshoot. I have no idea what I'm doing here. So then what we're going to do is we're going to say, let's see, up here outside of the step function, we're going to actually, well, let's actually, like, generate our map, right? And our map to start with is just going to be one city on this map. So so our generate function, and I'm actually just going to call that generate function down here so I don't freaking forget. And we're going to say, oh, you know, we'll do this the simplest way first of all, right? Var first city equals city, and it's at 0, 0 right now. So it's probably, let's make it at like 100 to, because 0, 0 might not even render. So we'll generate this city here. But actually, this is, you'll notice that this is scoped to the generate function here. What we actually want is a global variable called cities here. And then what we want to do is just push a new city to cities. So this is going to create an array of objects called cities. And then what we can do is we can go through each member of the cities array and call the draw function every step. So for var I equals 0, I is less than cities dot length, I plus plus, and then we just say cities sub I dot draw. We just call the draw function for it. Now we only have one city here. That's okay. Let's see if this even works. It's probably not going to work. This stuff never works the first. Oh, it worked. It worked. All right. So now we have one city. Let's draw another city. So this time, let's make the cities appear somewhere at random. So we'll do math.random times, I know that my canvas is 1,000 pixels long and 600 pixels high, so we'll just do that, 1,000 math.random times 600. And hey, it's at a different place on the map now. Well, look at that. That's super great. So let's make a bunch of cities. Let's make 1, 2, 3, 4, 5, 6 cities. Now we have 6 cities on our map. Well, that's pretty cool. How about we render the name of the city? That's probably important. So we'll do ctx.fillText. So we're just going to go into our cities draw function here, and we're going to draw the city's name, and we're going to do it at our x-coordinate, but you know, a little bit above it. So I don't know, 40 pixels. And then we'll do, oh, sorry, that's the x-coordinate. So yeah, to the left a little bit, sure. Dot 40, and this dot y minus 40. We can play around with these offsets later. It doesn't really matter. We just want to make sure, hey, there's our labels. All our cities are labeled now. I don't like how far away those are, so we're just gonna, like I said, you know, we're just gonna mess around with these numbers a little bit until they get closer to the point where we like how it's all matched up. All right, that's pretty cool. That's good enough for now. So all right, so we have this map, and there's all these cities, and but they're not doing the language thing, right? We want them to do the language. They're all called city right now. That's boring. So what we're going to do is when we make a new city, well, for starters, let's just, let's just do the regular expression that we just made. And you'll notice that I have like a common pattern when I'm developing here, which is that I just do the simplest, most awful, boring thing first, and then once that works, I move on to the next thing. Like I'm always mitigating risk. I'm trying to make sure that things don't get too complicated. Hey, look at that. We have cities now. There's Kadulka and Kadelka. That's kind of cool, actually. Those two are right near each other. That's totally random, though. And I can reload, and we've got new cities. Sometimes cities end up right on top of each other. We might write some code later to make sure that that doesn't happen. But for now, this is pretty cool. We've already got all of these linguistically coherent cities. So, all right. So we've got that happening. That's pretty cool. Let's capitalize the first letter of the city because. Yeah, because that's... So let's actually just generalize this into a global function called name city. And we'll go function name city and return our old code there. I'm not even going to change this right now. I'm just going to make sure that that still works, and it does. And then instead of... So var result equals, and we're going to return result, and we're going to make sure that still works. Yes, it does. And now we're going to capitalize the first letters. So gee, I could like spend a few seconds actually figuring this out. I guess I could do that instead of looking it up on Stack Overflow. So var city equals hello. So I want to make the first letter of that capitalized. So we will do city sub 0 equals city sub 0 dot to uppercase. Does that actually, but see, that's not, I uppercased it, but I didn't replace that value. So what I actually want to do, you can do a splice, I think. Let's see, city dot, no, slice. So if I sliced the city and just pulled out, nope, that's okay. We'll just look it up in Stack Overflow. Uppercase the first letter of a string. JavaScript. Haha, it's shameful, but I've got better things to do with my life. Hey, I knew it involved uppercase and slice and all those other things. Okay. And hey, there we go. We've got capital letters on our cities now. Hooray. Okay. So we've got city names generating and all that good stuff. So that's fun. That's cool. But what we actually want to do here is generate these isoglosses, right? At least in the background, right? We want what we want is areas of influence, like regions of influence for different sounds. So one thing we could do is we could parameterize the regular expression. And what I mean by that is we can break up the regular expression into a bunch of little pieces, and then each of those little pieces gets its own distinct geographic area. So, and what I mean by that is, so again, we'll, can I just, is it possible to just clear this? I've never used this thingy before. Oh, that, nope, that didn't do the trick at all. I'll just hit undo a bunch of times, I guess. There we go. All right. So what I mean by this is, you know, we have our map, and what we actually end up with are these regions. And so, like, this is where Al is, and this is where Ba is. And so a city in this region might be called Al, and a city in this region might be called Baba. And then in here, we would get Alba, like right there in the middle, because it exists within those two regions. And as we add more of these regions to our map, the names of the cities will get more complex, more city-like, and there should be enough complexity in here to actually make it possible for us to for the algorithm to surprise us, which is really why I do this, right? I want to like look at a map and have it surprise me. Apologies for my cough. I'm getting over a cold. So, all right, how do we do this? Well, first, let's figure out how to build a regular expression from strings. The way we do that is we go to Google and we type in build a regex from string JavaScript. Hey. No, that's, yeah, okay, it's this new regex, right, syntax. So if I go in here and I say var regex equals new regex, and then I say foo bar plus, so I'm like concatenating two different ones here, ka ba, yeah. Now we have this regex. So that worked. So okay, we will, what we're going to do is in our generate function here, before we generate any of the cities, actually up here globally, let's create a list of strings of pieces of regular expressions. So var, I don't know, syllables equals, and I'm just going to make a list of them here. So let's start with the ones that we already have, right? So, oops. So we have that piece, and we have this piece, and we have this piece. And let's put our commas in there so no one gets mad. All right, and then what we're going to do when we make a new city, we have our name city function, and so what we're going to do is we're going to say we're going to generate a new regex, and that's going to go in here. And what I'm going to do to start with is I'm just going to say syllables dot pick. I'm just going to have it pick literally just one of those things there. And we're going to make sure this runs. It does not run. Regex is not defined. Oh, yeah. Okay. So there's our ba, L, U, L. There's a K, there's a B. So that's working. But what we actually want to do is pick two in a row and concatenate them, right? So we're just going to do that next. And again, this is really stupid, but it's going to kind of work. Baal, Baka, Hallel, Zel. All right. You know what? Let's just do it again. Hey. All right. So now we're getting a lot more, even with just the same number of syllable groups, we're getting a lot more linguistic variation, but it's still not tied into the that isogloss stuff. So I think what we're going to need to do next is actually generate one of these isogloss areas. So what we're going to do is we're going to make another object, and it's basically just going to be like a city, pretty much. But instead of a city, we'll call it a gloss. I don't know. Like a city, it's going to have a random x and y coordinate as its origin. Its name is going to be just one of those syllable groups. And then its draw function is, we're going to make its area of effect be a circle. Just a simple circle. We don't have to get too fancy here. So as always, MDN draw circle canvas. Hey, drawing shapes with canvas. I know we have to use the arc function. I've done this a million times. Draw a... Oh, come on. Give me a full circle here. I just want to cut and paste the dang code. Well, whatever. We will... Oh, here we go. Right, so I probably just have to make it draw... Yeah, I just make it draw 2 pi as the arc. And it's got to be... And I got to use the stupid path thing. Path 2D? Is this new stuff? Wow. All right. Well, let's give it a shot, I guess. So we will make a generic draw circle function, just like we have draw line. Function, circle. We want to give it an x, a y, and a radius. And we're going to copy paste all this code in. And we're going to, so we make a new path. We make an arc. Our arc is, where's the arc? Lines, arcs, x, y, radius, start angle, end angle, anti-clockwise. So x, y, radius, start angle 0, end angle pi times 2, which is 360 degrees. And it doesn't matter what direction we're drawing in, because we're drawing a circle. And then we do circle, this dot x, this dot y, and I'm going to give it a radius of 100 right now just to see if this even works. And what we're going to do here is we will do the same thing where we, in addition to a bunch of cities, we will have a bunch of glosses. And before we push our cities, we will push a new glosses.push gloss. What are we at here? Is this going to work? Let's find out. Well, it's not erroring out, so that's excellent. Oh, right, we have to draw it. Hey, all right, there's our gloss. and that's appearing at random points on the map as well. So let's make a bunch of them, like a whole bunch. I don't know. Awesome. And then let's make these pretty big, actually. So let's just make them all, instead of 100 radius, we'll make them, well, I'll make radius a, let's call it range 500. And then we'll draw this dot range here. Okay, that's maybe too big. 200. That's maybe too confusing. Let's draw a few less. Okay, all right, I can handle this. So we've got our gloss areas. Now we have to be able to make these glosses actually affect what the cities are doing with their names. So basically, we need a way to tell if I'm going to put a city inside this, if I'm going to put a city like here, like right here. Hopefully you can see my mouse cursor, but like in the middle of one of these circles, I need to be able to tell how many of these circles the city is intersecting with, that like point x, y. So what I want to do is I want to make a function that basically says, for a given point, which of these glosses am I colliding with? And so this is what's known as a point-circle collision in a point-to-circle collision in game development. And fortunately, these are extremely easy to check for, although I haven't done it in a while, so I will probably mess it up, and that's okay. Messing up is part of coding. So we'll make a function called point-to-circle, and we're going to give it an x and a y because that's what we're testing, and then we want to return an array of all the circles, of all the glosses that it collided with. So actually I'm going to call this point to gloss because it's not as general as that. We're going to be looking specifically at glosses here. We're going to return result. Result is going to be some kind of array. And you know what? Let's just make sure that this works. I know this is like the function doesn't do anything, but I always just, I'm not unit testing, so I just want to like check, that this stuff works. So, all right, so we've got, we're getting an empty array back. So now what we want to do is fill this array with glosses that overlap with the particular point. And so what we want to do is we probably want to go through each one of our glosses. For var I equals 0, we can use each, right? There's this great, or for each rather. There's this great for each where I can do something like this: function gloss console.log gloss. Hey, it just went through and is giving us every gloss there, so I don't have to do any of that for loop stuff anymore. So we'll do glosses.for each function, the individual gloss, and then what we're going to do is we're going to have to test whether this XY point is inside of this gloss. And so the way that we're going to do that is I'm going to sit here and think for a few seconds. Well, we can like reason through this, right? I've done this a million times before, but it's been a long time, so we can reason through this, right? We have a circle, and we have our coordinate system here, x, y. Although it's the other way around on a screen, that's probably just going to confuse everything. So we'll just go back to our circle here, and we have a point here that collides. And we have a point here that doesn't collide. And so it's like, what's the difference between these points? Well, the circle has a center point of its own. And all we have to do to reason about this is, and it's got a radius, r. And so all we have to say is the distance of this point that we care about greater than or equal to r from the center of the circle. If it's greater, then we're outside the circle. If it's less, then we're inside the circle. That's it. That's all we need to do. So what we need to do next is write an equation to find the distance between the 2 points. Well, fortunately, that's where our old friend the Pythagorean Theorem comes in. I'm sure you remember that. So we want to find the distance from here to here. Well, all we're going to do, let's just assume we have a regular old Cartesian coordinate system. Well, we want to find the distance of this line, so the length, and so we just sort of draw an imaginary right triangle here. And if this is our xy coordinate here, and this is x1, y1, then it's the length of this CAB, right? And so it's c squared equals a squared plus b squared, right? Or we take the square root of all that stuff, and then we get c on both sides. And what are we want to get c? What are a and b? Well, a is just the difference in the x values, and b is just the difference in the y values. So what we're going to do is we're going to make a distance function. Function dist x, y, x1, y1. And what we're going to do is we're going to say, okay, return math.square root of a squared plus b squared. So a is, let's just make this var. A is the distance between x1 and x. Var b is the distance between y1 and y. And so we're going to do a times, well, it doesn't really matter, a times a plus b times b. And this should give us our distance. If we go for the iconic 3, 4, 5 right triangle, let's see, so that's 0, 0, 3, 4. It gives us 5, so that we know that works, and that's just a handy thing, because I know that a right triangle that has a length of 3 and 4 on both of its sides is going to have a hypotenuse of 5. So just a nice quick way to check whether that's right or not. So we know that that's right. We have our distance function now. So now we just need to find the distance from the center point of the gloss to the point that we're testing. And so what do? Well, we say that distance is just gloss.x, gloss.y, and then we're comparing it to x and y here. And so what we're doing is, so if this distance is is less than gloss.r, then we are inside this gloss, and we'll do something in that case. And then otherwise, we just don't do anything. And so the thing that we want to do in the case where this is what we're dealing with is we want to actually just push the gloss to our result array. And now we're going to return an empty array if there's no collisions, and we're going to return an array full of glosses if there are some collisions. So here's a new map. And fortunately, this is a pretty good layout. I know that this lower left corner here should be inside of this particular gloss. So, and since I know the dimensions of our canvas, I can say point to gloss, and so that's at 0. X is 0, excuse me, because it's all the way to the left, and then y is 600, I think. If I set this to 600. Yes, it's 600. So we'll just test that point. No, it didn't work. What's going on here? Point to gloss. Return result, gloss for each. Do any of these points work? Nope. Alrighty. Well, we can debug, right? console.log. So let's distance var distance equals that dist. We will console.log distance and gloss.r, and just make sure that we're like checking what we think we're checking here. So, haha, it was .range. That's what happened. All right, so now if I test 0, 0, it should give me back a gloss because we got that upper left. Yes, and there's our result. It's that al, el, il, ul. So now, if I wanted to get that regular expression, I could do that. So that's cool. Let's kill that console log because now we're this is working just fine. So now the next thing we want to do is we want to write a function where we count up the number of glosses that were inside at the point, and then we concatenate them all together into a master regular expression. So we'll call it aggregate glosses in the interest of being super wordy. And we're going to do that at a point. And so the first thing we're going to do is we're going to get a list of glosses that we overlap with. So, and that's just going to be our point2gloss function here. So we're just going to do that. So we're going to get that array. And then what we want to do, so if we picked up if I pick something from like the middle here, so that's like 500, 300, this should give us a bunch of results. Yeah, so this gives us 3 different glosses. And so what I want to do is actually I want to go through each one of these, and for each gloss, I'm going to do something like, well, we can just print out, for starters, we can just print out gloss.name, right? And so this gives us our list of glosses. What we can actually do here is a reduce function. This is a fancy, super fancy schmancy functional programming thingy. We're going to do a reduce here, and I just need to remind myself it's previous value, current value, index array. Okay. Hopefully this works. I usually use underscore or low dash or something. So prev gloss index array. Hold on. What's our initial value? Oh, and the initial value comes after the callback. Got it. So our initial value for this is going to be a blank string, and then we are going to return the previous value concatenated with gloss.name. Hey, there we go. Magic. So now we get this big regular expression for inside of there. So that's our whole function right there. So we are going to do actually don't even need, I can just return point to gloss x, y. Yeah. Ta-da! And so now, if we do aggregate glosses for 0, 0, this should just give us an empty string, which it does because there's no glosses up there. But if I pick, like, I don't know, 100, I don't know, it looks like maybe 500. Hey, there we go. So it's the combination of both of these two CK, BZD things. So now what we want to do is use this aggregate glosses function to name our cities. And so what we're going to do is, so we already called this name city function when we name cities. But now what we actually want to do now is pass in our x and our y, but we can't do that because we haven't. So what we'll do here, this is nice. What we'll do is we'll just set name to be a blank string right now, and we'll create an initialization function for this. So we're just going to call it init, and this is just going to happen when we create the object first. And so what we're going to do is we're going to say, all right, name this dot name equals aggregate glosses this dot x, this dot y. So by the time we run init, we will already have an x and a y coordinate for this guy. And so what we have to do is when we create these cities, the first thing we're going to do is actually var city equals city dot, or equals city dot init. Oh, so yeah, I could actually just chain it like that, probably. So we're going to create the city, we're going to initialize it immediately, and then we're going to push it onto our array. No, cannot read property draw of undefined. Okay, all right. Oh, right, because this is not pushing the city. This is pushing the value of init, which is just a string, or not even a string. It's just undefined. So yeah, we will do var city equals city, and then city dot init, and then we'll push the city. City is not a function. City is totally a function. What are you talking about? Oh, right, because I'm naming it city. My city. There we go. And there's our little city right there. And you can see that it's inside that border and it has the right name. If I reload and it's outside of a border, it doesn't have any name. And I reload again and I reload again. Oh, there's one. Oh, but it's not doing the actual name. It's naming it the regular expression itself. That's okay. So what we'll do next is we'll make name city actually work. So this dot name is not aggregate gloss. This dot name is becomes name city, and we'll pass our x and our y variables to this function. And then our regular expression here becomes aggregate glosses x, y. And now, oh, there we go. The city of Ul lives in the Ul region there. The city of B lives in the B region. We'll wait until we get like a decent overlap here where the city is actually named something nice. KK. So we can tell right now that that something's wrong with our system here, because there's a lot of points on the map where cities can't be named anything, and there's a lot of points on the map where city names are just going to suck. So one way we can change that is just by making a whole bunch more glosses. So let's do that. This is going to make our map a lot harder to read, but it's going to make our cities have a better naming, like Zaza there. I think the other thing that I want to do is not make all of these glosses uniform in size. So I could make a very large gloss that's basically the size of the entire map, and that could be like a default gloss that just has some basic stuff in it. Let's make a few more cities though first. So we're actually going to do var my city, and then my city equals 4, var I equals 0, I is less than 10, I plus plus. Yeah, that should work. Cool, so now we have like 10 cities going on here, some of which actually have like reasonable city type names. So hey, cool, we have this map, we have all this cool linguistic stuff going on. Oh, I'll make that giant gloss. So what I'll do here is down in the gloss function, I'll give it an optional parameter. We can optionally specify range, and range is either range or 200. And so we do that. This should just be the same as always. Yep. And then I can make one gloss that is really big. Like huge. And now there should be no unnamed cities. Yeah, so that's, oh, well, let me make a lot less glosses now just to make sure that this like works the way I think it does. Yeah, so you can see we have any of the non-already, covered regions already have this al, el, il, ul thing going on. So I could actually build a default regular expression there as well. So what we should actually do here is we'll go to gloss here, and we'll make an options object. And our options object can have a range. So var range equals options.range or 200, and var name equals options.name or syllable or syllables.pick, which was kind of our default there. And so now name becomes name. And up here we could pass nothing, which would just do the default thing. If I pass an object to this one with a range of 2000 and a name of cake, something's not options. Oh, right, I have to set a default options object as well. So if I don't pass it in, it's not undefined. Oh, what happened to cake? That didn't work. Glosses. Oh, no. Range, name, glosses.push. Let's look at our glosses. Let's look at our last gloss here. All right, we didn't set the name right. Oh, right, because it's options.syllable. Haha. Because I decided to be. So, syllable is cake. And there we go. So now the cities by default are called cake. And then in here we have butt cake and cupcake and so on and so forth. So what I could do is I could set like a default regular expression here that I like. So for example, we can just play around here. Let's do F, J, sh, so like kind of soft sounds, and then a set of vowels. Fo, fa, fi, jo, ja, ji, sho, sha, shi. Okay. And so I generate those, and I get jo, fa, shi, fa, those things like that. Let's just repeat it. It'll just be funny sounding. Sheesh, jodge, jeej. Repeat the whole thing. Gigi, Jojo, Fifi, Shishi. So we'll make that, oops. We'll make that our new default here. We didn't have any cities that lay outside. Basha, Zasha, Batha, Shisho. Interesting. Oh, right, because we have the capture thing now, and we're right. Is that going to work better? Ify leaf. Right, so these aren't going to work out. I can't do those repeat things because I have no control over the order in which they appear. But I'll just do this twice. Jaji, Shoshi, Fija, Jajo, and then in here it's old Jifi, and so on and so forth. So now, let's make our default gloss size a little bigger. Our range, make it 400. Yeah, that's cool. And then we will, let's stop drawing our glosses. So that's all in our step function here, and we'll just comment out the glosses.draw. All right, and so now we've got this map here where stuff in the sort of right side of the map is like ulil type of names, and then we've got more like al, bal, shoshi things going on up on the upper right. And so this is actually like, this is pretty respectable, you know. Like these two cities, Al-Jasho and Ulfoja, are near each other, and these really long named ones are near each other, kind of. Shaja and Shasha are near each other, and so, you know, we're starting to build these things out, and that's actually like really kind of fun. And so now that we have this framework built in here, you know, we can just start playing. We can be like, you know, what's I don't know. Ax, Bak, Pak, and Axan, Bakan, Pakan, Axor, Pakor, Bakor, Axil, L, right? And let's maybe repeat that. Bakopokor, Bakan Axel, Axel Bakan. So we can take these and add these to our sort of generic list up here. Oops. And now we added some new syllables here. So our names are even Orkshijo, Befaja. Befaja. How'd that one even happen? Oh, it's because we have this this group of consonants here. Let's get rid of that. Nice. Yeah, and so we have these like outlying cities that don't have very long names, and then I don't know, maybe this is like in the middle there is like a metropolitan area where like the cities just have like all these honorifics attached to their names or something like that. You know, the great city in the sky ascending to the heavens type of thing, and then like, you know, a crappy city on the outskirts of town is just like mud pit or something. So there's a lot you can do with this. There's a lot we can play around with for this, and it can get seriously a whole lot of fun. So yeah, we set out to build something that looked sort of like this, and now we have something that looks sort of like this. So that is pretty freaking cool. I've been talking for about an hour now, so I think what I'm going to do is, hang with me for a moment here, you're going to get like a little recursion moment while I change the screen share off. And I think what I want to do now is just check Twitter, because I have been ignoring Twitter because I don't want like Twitter mentions to just pop up in my on my stream. And people were saying they couldn't see the screen. I hope it worked. Anyway, I guess we'll find out once I stop broadcasting and I go check the video. So thank you very much for watching, and if I have to do this again later with a working screen, we'll figure that out. Once again, thanks, and I hope you found this enjoyable.